Imagine you're standing on a quiet beach, and suddenly a single grain of sand hits you with the force of a speeding train. That is essentially what happened in 2023, when a neutrino, one of the smallest, most elusive particles in the universe, slammed into Earth carrying more energy than any particle ever recorded. Its energy was roughly 100,000 times greater than the most powerful collisions produced by the Large Hadron Collider, humanity's most advanced particle accelerator, and that single detection forced physicists to ask a wild question. Did a black hole just explode somewhere in the universe? The neutrino was detected by the KM3NeT Collaboration, a massive neutrino observatory buried deep beneath the Mediterranean Sea, designed to catch faint flashes of light produced when ghostly cosmic particles pass through water. Neutrinos are famously difficult to detect because they barely interact with matter, and trillions pass through your body every second without leaving a trace, but this one was different because it arrived with an absurd amount of energy, so extreme that no known astrophysical engine, not supernovae, not supermassive black holes, not even the most violent gamma-ray bursts, can comfortably explain how it got that powerful. So physicists began looking for something more exotic, and that is where a team from the University of Massachusetts Amherst enters the story with an idea that sounds like it belongs in a science fiction blockbuster but is grounded in serious theoretical physics. They proposed that the neutrino could have been produced by the explosion of a very special kind of black hole known as a quasi-extremal primordial black hole, and if that sounds complicated, do not worry because we are about to unpack it. Most black holes form when massive stars collapse under their own gravity, becoming dense stellar corpses that can sit quietly for billions of years. But primordial black holes are different because they would have formed in the chaotic first moments after the Big Bang, when the universe was a violent ocean of energy and tiny fluctuations in density could have compressed matter into microscopic black holes. Think of the early universe as a pot of boiling soup, and in that turbulence, tiny pockets might have collapsed into miniature gravitational traps, far smaller than the stellar monsters we usually imagine. Now here's where things get even more interesting, because in the 1970s the legendary physicist Stephen Hawking showed that black holes are not completely black, since quantum effects near their event horizons cause them to emit particles in a process now known as Hawking radiation. You can think of it like a cosmic savings account that slowly leaks money. The smaller the black hole becomes, the hotter it gets, and the hotter it gets, the faster it radiates away its mass, creating a runaway feedback loop that could eventually end in a final, violent burst of particles. If a primordial black hole were small enough, it would not last billions of years but instead gradually shrink and then explode in a last dramatic flash, releasing a shower of particles that would act like a catalog of the universe's most fundamental ingredients. It would not just release familiar particles like electrons and quarks, but potentially Higgs bosons, hypothetical dark matter particles, and maybe even entirely new particles that no experiment has ever observed, almost like smashing open a cosmic piñata and seeing what fundamental confetti spills out. The UMass Amherst team, publishing their findings in physical review letters, argues that such explosions might even occur as often as once every decade, meaning we could realistically witness them with existing observatories. And when the ultra-powerful neutrino was detected in 2023, it looked like the first dramatic clue that this theoretical picture might be real. However, there was a twist in the plot that made everything more complicated and therefore even more exciting, because another major neutrino observatory, the IceCube Neutrino Observatory in Antarctica, did not detect a similar event and has never observed anything remotely as energetic, which creates a mystery because if primordial black holes are exploding frequently across the universe, then Earth should be bathed in high-energy neutrinos far more often. This is where the idea of a dark charge enters the stage like a hidden power-up in a video game. The researchers propose that some primordial black holes might carry a kind of charge that is not the familiar electric charge we learn about in school, but a mirror version operating in a hidden sector of physics, complete with its own heavy counterpart to the electron, which they call a dark electron. These so-called quasi-extremal primordial black holes would behave differently from simpler models, holding onto their mass longer and releasing energy in more selective, intense bursts that could explain why one observatory detected an extraordinary neutrino while others did not see a steady flood of them. To visualize this, imagine two types of fireworks. One that fizzles out gradually in every direction, and another that stores energy tightly and then releases it in a single blinding flash. The dark charge black hole would be more like the second firework, producing rare but extraordinarily powerful particle emissions, making the 2023 neutrino not a contradiction but a signature of a very specific, exotic black hole behavior. And here is where the stakes skyrocket, because this model does not just explain a single neutrino. It potentially touches one of the biggest mysteries in cosmology, which is dark matter. Observations of galaxies and the cosmic microwave background strongly suggest that most of the matter in the universe is invisible and does not interact with light, yet we do not know what it is made of. If these dark-charged primordial black holes exist in significant numbers, they could account for the missing mass, acting as the invisible scaffolding holding galaxies together. So in one sweeping theoretical move, this idea connects an ultra-powerful neutrino, Hawking radiation, primordial black holes, hypothetical dark sector particles, and the mystery of dark matter into a single narrative. It suggests that by detecting one impossible particle, we may have opened a window into physics beyond the standard model, and perhaps even glimpsed experimental evidence of Hawking radiation itself, something physicists have been hoping to confirm for decades. Whether this model turns out to be correct will depend on future observations and whether we detect more of these extreme neutrinos, but the fact that one tiny particle forced scientists to rethink black holes, dark matter, and the fundamental structure of reality shows how the universe sometimes whispers its deepest secrets in the most unexpected ways. And if that neutrino really was the echo of a dying primordial black hole, then somewhere in the vast darkness, a miniature cosmic monster may have exploded, and in doing so, briefly illuminated the deepest layers of the universe.